All right, so the problem we're going to try to solve is this. If 25 grams of water at 25 degrees C is cooled to negative 15 degrees C, how much energy will be given away? And I gave you the enthalpy of fusion, and I gave you the specific heat for solid water because you don't have to memorize those. You do have to memorize the specific heat for liquid water. So what we have here is a sample of water starting at 25 degrees, and so we're starting in liquid form, okay? And as we cool the water, it's going to cool down to 0 degrees C where it's going to freeze. And then after we freeze it, then we cool it down again to negative 15 degrees C. Okay? And this is going to be ice. It's not going to be liquid anymore. Okay, we're starting at liquid here at 25 degrees. And you need to know that between 0 degrees C and 100 degrees C, water is a liquid. Okay, below 0, you have ice. And during that phase transition, something kind of happens that's funny here. Now, the equation for figuring out the energy lost during the cooling of liquid water, that's Q equals mass times the specific heat times the change in temperature. Okay? Then while we're freezing it, there's no temperature change. So we can't use this term here. We have a different equation. It's Q equals mass times change in enthalpy. That's the heat in the system in this case. It applies to this case. And when we get to cooling down the ice from 0 to negative 15, then we use Q equals mass times specific heat times the change in temperature. Now this specific heat is different from this one. This is the one for liquid water. This specific heat is 4.18 joules per gram per degree C. Okay? This specific heat is given to you right here, 2.05 joules per gram per degree C. Okay, the mass doesn't change. The mass for all of these stays the same, 25 grams. The delta H term here, I gave you to you up here, is 334 joules per, let's put other grams like this. Okay. And so all we have to do is just solve these three problems and add up the amount of energy lost. Okay? So while we're cooling the water, we have Q equals mass, 25.0 grams, times 4.18 joules per gram per degree C times the change in temperature. And the change in temperature is always, delta T, is always temperature final minus temperature initial. Okay? The final temperature here, when we're cooling the water, it can't get any cooler than 0 degrees C. Final temperature is 0.00 degrees C. The initial temperature is 25 degrees, right? So the change in temperature term, right here, that goes here, is negative 25.0 degrees C. Does that make sense? Any questions about that? All right, grams are going to cancel. Degrees C are going to cancel. This is going to tell us how much energy is lost. Joules measures energy and work. Okay? So I know somebody already has the answer to this. What's the answer here? 2.61 times 10 to the... Is that the unrounded answer or the rounded answer?
So that's the rounded answer. The unrounded answer is 261
2,612.3, right? Okay, and that's joules. And we need to round our answer to 3 significant digits because this number and this number and this number all have 3 significant digits. So we're going to round off a number in the ones place. If we round off a number in the ones place, then yes, we have to write it in scientific notation. So we're going to move our decimal place 1, 2, 3 places. 2.61 times 10 to the third power joules. And that's the energy lost while we're cooling down liquid water. I'm sorry, you're right, it is negative, because that's negative. Okay? All right. So then when we're freezing the water, that's where we're going to use this equation here. So that's Q equals the mass of 25.0 grams times the delta H, 334 joules per gram. But is the system gaining energy or losing energy during freezing? It's losing energy, so this is negative. If delta H is negative, that's negative. Okay? So what do you get when you multiply those two together? What? Is that right? Down right? Yeah. I mean, I wrote down the numbers right. Yeah. Okay. And that's grams are going to cancel. So we're going to have joules. Going to round it off to 3 digits. So it's a negative 8.35 times 10 to the third joules. Okay? And then when we're cooling ice, Q is the mass hasn't changed. It's still the same sample of water, 25.0 grams, times, in this case, our specific heat is 2.05 joules per gram per degree C. And the change in temperature here is, you go from, it's always temperature final, which is negative 15, minus 0 where we started. So that's just minus 15 degrees is the temperature change. So grams are going to cancel, degrees C are going to cancel, and what answer do we get here? Okay, need to round it off to 3 digits. So we get negative 769 joules. And so to find out the total amount of energy lost in this problem, you need to add all those numbers together. So Q total is equal to all the 3 Q's added together. And somebody's already added those together. Somebody already added those together? Can you give me the answer here? Unrounded answer first. 29. Okay. Now when you add all those numbers up, line them up vertically, there's empty slots in the number in the first 2 columns. Oh no, the first column, just the first column. Do I need to add it up to show you how that works? Okay. Remember, we're rounding off this 2 right here. So I'm going to write it like this. I'm going to say 2,600 or 610 instead of 12, and put the arrow for that empty slot. Okay, because I can't have a 0 there. I can't have a 2 there. We rounded it off. I'm going to add that to this negative number here. And that started out as 8,350, but that 0 had to go away, so that's an empty slot. And this last number doesn't have anything removed from it, negative 769. We're adding all these together, basically, and we get 11,729, but that last digit has to be rounded off because there are empty slots up here. Okay? Does that make sense now? Okay, so this is joules, and that's joules, and that's joules. So our final answer is in joules. Move our decimal place 1, 2, 3, 4 places, 1.174 3 times 10 to the 4th place joules. Means they're going to round this off number over here to show the right thing. That's a negative number. That's a negative number. So negative 1.173 times 10 to the 4th joules.